In this lecture presented by www.free-academy.com, we're going to be discussing related rates. And in this related rates problem, we have an indeterminate beverage that is definitely non-alcoholic being poured into a martini-shaped glass. And the question is going to be, how fast is the liquid rising at a given position? How fast is it going? Because we're going to be pouring this liquid. Let's say that the volume is going to change by 1 cubic centimeter per second. And the dimensions of our glass is, at its top, it's going to have a radius of 10 centimeters, which also corresponds to a height of 10 centimeters. So you can tell at the bottom of the glass, we have a very, very, very small volume. In fact, 1 cc is going to raise your height up by 2 centimeters or something like that. But at the top, once you get very near to the top, you're going to have to add 10 cc's to go 1/10 of a centimeter higher. So our rate is changing, and we're going to explore the relationship between these rates. This is going to use our implicit differentiation skills that we had just learned. But now we got, instead of y and x, we have volume, radius, and height. And we're going to take all these derivatives with respect to time. So every single one of these is going to be a variable in time. Volume changes with time, radius changes with time, height changes in time. So I'm going to leave out all these t's, but these are all functions of a different variable. So lots of product rules and chain rules and all that kind of good stuff. Well, before we go any further into this, I have two equations written here. Our radius change is dependent with height. For every 1 increase in radius, we have a 1 increase in h. It's a 1-to-1 ratio. And then our volume is dependent on pi over thirds radius squared of h. We're going to implicit differentiate both these equations. But I'm also going to give you like a little formula about how to do these problems, because they do get a little confusing. Step 1 in any related rate problem is going to be define with equations. So taking the side of the glass there, I gave you the equation R equals H. Well, what they might do is they might just give you a couple points on this, and you might have to come up with that equation yourself, but you definitely would have to come up with the volume equations. Just get all your equations, get extra equations. It never hurts to have more information. Then the next step is going to be take the derivative of all your equations. So let's do that. d by dt of RH is going to give you R prime, H prime. Alright, so at this point you might be wondering what happened there. Why R prime, why H prime? Well, it's power rule. R to the 1, take the derivative of it, gives you 1R to the 0, R prime. Because of our chain rule as well. We did the power rule and the chain rule. This is 1, that's 1, so the only thing that's notices is R prime. Same story with H. The next equation, V equals pi over 3 R squared of H. This is going to get a little bit more interesting because we're going to have product rule right there, we're going to have power rule, and we're going to have chain rule all in one. So we're going to just suck out the pi over third to begin with. And our product rule is going to be take the derivative of the r squared times regular h. Derivative of r squared is 2r r prime. Now we go into the next term, where our r squared we don't touch, but then we take the derivative of h, which is h prime. This is all multiplied by pi over 3. So now we have the derivative of both of our equations. I'm going to bring up a new note here. But before I do that, I'm going to write for you guys the third step. I'm going to solve the equations. Alright, now we have that. Just put this into a place where I can see everything, copy everything over. Pi over 3 2r prime h plus r squared h prime, and then of course r prime equals h prime. V equals 1 centimeter squared per second. Max h equals 10 centimeters. Max radius also equals 10 centimeters. Now there's one piece of information that I've left out in this problem so far, and you know what, I'm actually not going to tell you that. We're going to solve these equations as best as we can before we go into that. So with our r prime equaling h prime, we're going to substitute all of our h primes in this equation. So this will give us pi over third equals 2r prime h plus r squared r prime. So now we're a little bit simpler there. Now I'm going to pose the final piece of the question. How is r prime changing at h equal 4 centimeters, r equal 3 centimeters, or r equaling 6 centimeters? We have enough information to do all of this now. So we know since we have a 1-to-1 ratio, when h equals 4 centimeters, r equals 4 centimeters. When r equals 3 centimeters, h equals 3 centimeters. And when r equals 6 centimeters, h equals 6 centimeters. We'll take these one at a time and plug them into our equation here. Oh, also keep in mind, wish I had said this before, this all gave us equal to, get my colors right here, this is all equal to v prime, which is 1 centimeter per second. It's a worthy piece of information that I wish I had stated before, or just carried over a little bit more conveniently. All equals v prime. So plugging everything in here, we'll do it for case number 1. Pi over 3, 2, r is 4, r prime, and then h is 4, plus 4 squared, and then r prime, and that all equals 1 centimeter per second. And it's really useful to follow your units. These would all be centimeters throughout here. I'll just leave them out for now, because they might get in your way while you're learning. But you definitely do want to follow your units. Grab my calculator here and calculate some things out. This is going to be 32 r prime plus 16 r prime equals 3 over pi, which equals 48 r prime, 3 over pi. So r prime is going to be equal to 1 over 16 pi. when h equals 4. And these are centimeters per second because we took the derivative with respect to time. Now I illustrated these couple other examples. I'm not going to follow them through, but for case 2 where r equals 3 and h equals 3, you would just plug 3's into there and so on and so forth. The most trouble you're going to have, and you saw the trouble with me a little bit here, is keeping all your variables straight, all your equations straight, and making sure you have enough information. Probably, if you're going to have trouble with these, your problem is probably going to be that you don't have enough information. Get yourself 10 times more information than you need. Hope this was helpful. We'll definitely do more practice examples on the website.